All right, so let's start this and see where we left off. So we're supposed to have an edit text that allows us to type in the number of elements. Then we generate an array of that size, fill it with random numbers, and then sort it and put the elements of the array into text views and throw them into the scroll view. That all sound accurate? All right, so here's our example from last time where we had a bunch of text views that we threw onto a scroll view. So now we want to have a specific number of text views. So let's start off, and this is on screen 2, so we'll repurpose screen 2. Let's go to our activity main. Let's dump these extra buttons. And let's go ahead and let's throw an edit text up there. So we're going to put a hint in here. Where's the hint? Big money. All right, so enter the number of random numbers. And in this case, since we are reading in numbers, we can choose this guy here for the keyboard type. You don't have to do this, but if you want to limit them to a certain kind of keyboard, you can choose the input type here. Drop it down, we'll uncheck that, and we're going to say we want a number. And then hit OK, so it'll give us a keyboard that limits us to just numbers. I'll show you that real quick before I do anything else. Oh, hold on. I no longer have these page 3 stuff, so let's comment out some of those things. So we'll get rid of, I'm going to get rid of all my buttons. I don't need to know about the buttons anymore. I'm going to steal that text for right now. I think it should run now, and then we'll go back through and rewrite a lot of this. So now when I select that, notice it's giving me just a keyboard with numbers on it. So it gives you a little bit more control over your input, that type of stuff. Okay, so we want them to enter in a number of numbers here. Then when we say go to page 2, we want it to go ahead and, well, we have a couple of options. We could generate the array here and have it fill the array up, then pass the array to page 2. Or we can pass the number of elements to page 2, have page 2 generate the array, and then fill up the scroll view with the elements. Doesn't necessarily matter. In either case, page 2 is getting an array. Does that make sense? So let's go ahead and why don't we just pass the number to page 2. So I'll get rid of all my array stuff here. And we'll go ahead and get rid of our on restart as well. We don't need to use it this time. And I'm going to get rid of my array there. I'm going to get rid of my array and my object here. We're just gutting the thing back to kind of its original start point. All right, and we want to go ahead and we want to maybe have array count is the extra we're going to put in there. And the array count we want to get is going to be, now we need access to that edit text. So we're going to come back out here to main activity. We're going to call this guy input ET. Call it whatever you want, but that's a reasonable enough name for our edit text. So we can read in the number from that. Now we'll go to our, let's close screen 3, keep screen 2 open, close screen 4. All right, good enough. We actually don't, well, I'll leave core open, it's not hurting anybody. All right, so we need to give ourselves access to that edit text. So up here, we're going to have a private edit text input ET. Okay, so that is our edit text. And now we need to go ahead and retrieve that. So this is the MVC portion of this. So we'll say this dot input ET is equal to the edit text version of this dot find view by ID r dot ID dot input ET. Now we have access to that guy. Now, when we go to the next page, we only actually want to go there if we're going to put in some error checking. You didn't have to do this, but if you wanted to, we're only actually going to go to that second page if we have some stuff entered into our edit text. All right, so maybe we ask the question, if this dot edit, or what do we call it, input ET dot get text dot toString dot length is greater than 0. So if they gave me something that's bigger than 0, that means I have a number that I can parse out of there and send to the next screen. So only then will I try to do something. So I'm going to be going to screen 2 here. My array count is going to be equal to integer.parseInt. So I want to convert a string to an integer. What string? This dot input ET dot get text dot toString. So that's the string I want to convert into an int. Now, if you don't like doing these big, long strings of stuff like this, where you kind of link a whole bunch of functions together, that's okay. You can do something like string number, maybe call it number text, is equal to this dot input ET dot get text dot toString. So it'll give us the string version of that guy. Then I can say int number is equal to integer dot parseInt number text. And then here I can pass in number as the value for array count. It's ultimately doing the exact same thing, just I'm storing it in some intermediate variables here. I'm holding the string version of it, then I'm holding the number version of it, then I'm passing the number version of it to my put extra. This uses a little bit extra memory, but not a big deal. All right, so on our second page, on our screen 2, we will have an extra that will be arriving through the intent called array count that I can extract and use to build my array. So I'm going to steal that name so I make sure I spell it correctly. This will take me to that second screen. And just to test this real quick, I should, when I run this, if I don't type anything in there, I should not be able to get to the second screen right now. So if I just hit go to page 2, nothing happens. If I put a 5 up there, now I can get to page 2. Page 2 is crashing because I'm trying to do some stuff up and start on page 2. We're going to go and fix that right now. We haven't touched that today. So here's screen 2. And here's all this stuff I was doing in there. So first thing I want to do is I want to get, let's name it the same thing here. Array count is equal to this dot get intent dot get extra. So we're going to get a int extra, and the extra we're going to get is called array count. Oh, that's interesting. So get int extra makes us give it a default value in case the value's not there. So we have to tell it the name of the variable we're trying to retrieve, and then the default value in case we're not able to retrieve it. Give it 2 pieces of information. Makes enough sense. This keeps us from having to ask the question, is there an array count value? If so, store it. This guy's doing it for us because this guy is guaranteed to give us an integer. He'll give us either the value of array count or he'll give us a 0 in the event that it couldn't find it. Under the hood, it's still having to ask a question. We just didn't actually have to do the question asking stuff. All right, so we'll get that guy. So then in here, this is where we're grabbing our view group. Remember our view group, this is one issue where there's a difference between iOS development and Android development. In iOS, a view is a collection of other views. In Android, a view is just something you see. And a view group is a collection of views and view groups. So you can have a view group inside of a view. You can have a view group instead of a view group. So if we kind of look out here, just to explain it more clearly, this linear layout is a view group. This constraint layout, which we didn't do anything with, that's a view group as well. So we have a view group that contains one view group. Inside of this view group is 2 views. But I could also put another view group in here. But what I can't do is I cannot put a view inside of input ET. Can't put a view inside of a view, and I can't put a view group inside of a view. Views don't know how to hold extra stuff in Android. In iOS, UI views know how to hold other views. It's the same model, they just split it into 2 different container types in Android. Okay, so back here in the screen 2 code, this is grabbing me that vertical linear layout. The thing that I'm going to use to throw my text views into. All right. Now what we want to do is we want to go ahead and we have the number of elements in our array, but now we need an actual array. So we'll go ahead and we're going to say int array AR is equal to a new int array count. That's the number of elements that'll be in there. And then we're supposed to fill it up with random numbers, right? So we'll say random R is equal to new random and then we'll say for int I is equal to 0, I is less than, how many elements are in AR? Who? AR.length? Or array count. Array count holds the number of elements. AR.length is a synonym for that because we built AR in terms of array count. So I want to go AR.length number of elements, I++. Each time through, we're going to generate a random number and we're going to store it in the corresponding bucket of my array. I'll say AR at bucket I. That's the bucket we're filling with some stuff right now. What are we going to fill it with? We're going to say R.nextInt. So this will give us random numbers in the range of all integers. What's the range of integers, roughly? -2 billion to +2 billion, right? Because a signed integer is a 32-bit signed number. So that's plus or minus 2 to the 31st power. You don't have to memorize that, but you probably should have almost accidentally memorized it by now, or it shouldn't come as a huge surprise when you hear a value in the range of 2.1 billion is the biggest int, and a value in the range of -2.1 billion is the smallest int. Okay, so this will fill it up with random numbers. Now what we're doing is we're going to go ahead and we're going to create a new, we're going to go through every element of our array again. We're going to create a new text view. We could have done these together. We didn't have to have them in 2 separate for loops, but we'll leave it separate for now. So we're kind of doing it step by step. This is fill the array. And then this guy is generate text views based on the array's content. That's what that second for loop is doing, even though we could have combined them together in one, because they're both going through the same number of times. So each time through, we're going to create a brand new text view. So this is going to generate us a brand new thing using this as the context. This is the screen we're putting it on. And we're going to set the text of that particular text view, the guy we just built, to the string version of that integer. So this is our nice little shortcut for converting an int to a string. You just concatenate it onto the empty string. So very powerful, even though it seems very simplistic. This is the advantage of Java being a string-based language. C# is equivalently powerful with strings. Swift is substantially less powerful, and so is Objective-C. The way they represent strings is just different. And then we'll go ahead and add our text view to our view group. And our view group, because that guy was a vertical linear layout, already plays by some rules, right? So when we toss a text view into that guy, he auto lays that out in a vertical fashion. So every basket we make, it just keeps stacking them up on top of each other. Make sense? All right. So we'll go ahead and run this right now, and we should get however many random numbers we chose on screen 1. We should get that many random numbers generated and displayed in no particular order, in random order, on screen 2, proving that we've generated the correct number of random numbers. All right, so again, I'll click this. It's not going to take me anywhere if I haven't put a number in there. Then I'll go ahead and put a number 10 in there. We'll go to page 2, and here's my 10 random numbers. If I go back and I change this to 100, I go to page 2, here's my 100 random numbers. Now remember, this guy scrolls like this because on screen 2, we have taken our here's our linear layout that holds the text view that says screen 2, and then it also holds a scroll view. And this scroll view holds one element, and that is our vertical linear layout. So because we've put this view group inside of a scroll view, which is also a view group, we know this guy's a view group because he's storing another view group. Right at the beginning of class today, we talked about that views cannot hold other things. So a view, the fact that this guy is holding something else means it's a view group. All right, and a scroll view already plays by certain rules. He says, I will scroll whatever is inside me. And this guy is holding a vertical linear layout. And as that vertical linear layout, whose height says wrap content. So that vertical linear layout, see right now, it looks completely flat. As it starts filling up with stuff, it's going to get taller and taller and taller and taller, because its height will wrap whatever content's in there. Okay? And then the scroll view says, whatever's inside, I will scroll. Because once that guy gets enough stuff in there, he's going to take up more theoretical space than our screen. And then the scroll view says, automatically play by those rules. Scrolling in Android is substantially easier than scrolling in iOS. iOS has a UI scroll view. It has a similar type of widget, but it doesn't play as nicely. It takes a little bit more setup. Okay, go ahead. Chunk of your screen, like where?
On the right. So, like the size of the match. I don't fill out the screen.
Okay. So you mean not there, but in the emulator?
No, not here. I think on the first one.
This guy?
Yeah. No. The main. The main activity. Yeah, you see that should from the end of the screen to the end.
Yeah, from like here to here?
Yeah. But and my phone is 6 feet, next to 6 feet, and the rest is just.
Okay, my guess is that maybe has something to do with this constraint layout, although it says match parent. is it maybe your, oh, I bet you it's that. The linear layout thing here, maybe it's the emulator. See, this bothered me. So when we put it inside the constraint layout, because this guy is, actually right now, he's set up to emulate an Nexus 4, even though he is a pixel, right? So now he's one of these guys. Oh, I'm on screen too. Yeah, so see how this thing kind of went off to the side here? Let's see if that makes a difference in how it lays out. But I'm almost positive it has to do with the constraint layout. Yeah, this guy still looks fine. But I have a feeling that the issue is that constraint layouts are relatively new, and a majority of my Android knowledge is older than constraint layouts. I know quite a bit about auto layout on iOS, so I just don't understand constraint layouts. So there's probably something with that. So the quick fix would be to go in here and move your linear layout to the top level, so it's, you know, instead of using constraint layout as the top level, use a linear layout as the top level. Yeah, because then it'll just squish to the sides. But my guess is constraint layout must fix some sort of problem associated with that, and I'm not sure how it ends up working. For me, the thing that bothers me here is this layout width and height, because that is, I mean, I would want this to match parent, and it won't let me do that. Yeah, so that tells me the constraint layout is constraining it. It's saying this is right. And I'm sure the explanation is pretty simple, but I'm not sure what it is for the constraints. Okay, so in any case, on our second screen here, if we put in 24, we have a whole bunch of, well, so it looks like we could fit 25 of them on this on our screen. So it's no scrolling right now because there's nothing to scroll, but we'd like to have these guys show up in order, right? Now, if we want to see it in two separate pieces, actually, I'll end up putting it in two separate pieces here. But for right now, let's just get them in there in order to begin with. So we want to sort that array. And we've written sorts before, right? So we'll go to screen 2. So once again, we're going to write a sort. And then I'll show you a quicker way of sorting. So we're going to say private void sort. This guy will take in an integer array. All right, we'll do kind of our insertion sort guy where he does the swaps. So what are we going to need for that? We're going to need our follower. Where I is equal to 1, I is less than ar.length, I plus plus. So we'll start off at bucket 1 in our array. We're going to start follower off as that element. So follower will equal I. And then we want to keep swapping. So we want to ask the question, is the current guy first of all, am I at the top of the list, or is there somebody before me I can compare myself to? So while follower is not equal to 0. So while I have potentially somebody I can compare myself to, and I should come before the guy before me. That is, AR at bucket follower is less than AR at bucket follower minus 1. Both of those things need to be true. There's somebody before me, and I'm supposed to be in front of him. I'm a smaller value than him. Now, as a reminder here, all of our modern programming languages are smart enough to know that an and is only true under what conditions? Both sides are true. So Java will, if this guy fails, if there is nobody before me, Java will not even try to do this side. Make sense? Because if it tried to do that side, it would fail. If follower is at bucket 0 and I try to compare myself to bucket -1, bad things happen. But it won't even get to that point because since it failed here, it knows that it has no chance of success. So why waste its time over here? All right, important concept. And that's something, it's not a Java thing, that's across the board in programming. So while both of those things are true, while I have something to check and I have and I'm supposed to win, then I'm going to go ahead and I'm going to do my swap. So we're going to have an int temp. So we're going to go ahead and say temp is equal to, and we could have defined temp in here if we wanted to, but I'll just put it beforehand. So we're going to say temp is equal to AR at bucket follower, AR at bucket follower is equal to AR at bucket follower -1. And then AR at bucket follower -1 is equal to temp. Preserve bucket follower, overwrite bucket follower, then overwrite follower -1 with our preserved value of follower. That does the swap. And then follower -. When we get past the end of this while loop, we have taken bucket follower as, well, started off as bucket I, as close to the front of our array as we possibly could. So now what do? We move to the next element in our array, reset follower, do it again. So when all is said and done here, this sort should bring all the elements in order. So now before, we're going to say sort array. So we're going to say this dot sort, and we're going to pass it our array. Now arrays, are arrays passed by address or by value? What's the difference? What does it mean to be passed by address versus being passed by value? Such a talkative bunch. This is exciting. It was on the midterm, wasn't it, Charlie? If I pass something by address, what am I passing? Passing a memory address. So if I get a memory address, if I give you the address to my house, okay, and you run there and you spray paint my garage, when I get home, am I going to know about it? Will I know who did it? What if I gave all of you the memory address? I will, because I have new security cameras. They're awesome. I'm trying to see if I can find a deer or a coyote or something that comes across my driveway. Somebody keeps putting things in my mailbox to tell me to get rid of my ugly boat. Huh? Yeah. Yeah. A fish. I used to have a really big, like, nice yacht boat. That's a whole nother story. But then my neighbor ticked me off. So I wanted to get a nice, like, fishing boat, like, you know, like a decent, normal size one you could pull with your car. And he didn't want me. We were in our homeowners association, said we couldn't have boats in our driveway, but we actually could because he sent me on this wild goose chase, and I researched it. I talked to lawyers and stuff. So then, what I obviously had to do is I had to get a really ugly boat, I got like an old 1978 boat. Sit it right there in my driveway. No cover or anything. Pretty sure it's him. I got to catch him in the act. So this is my entry. It was that, or I was going to get surveillance drones. My wife did. Thought that would cross a new line. Even if they didn't do anything, wouldn't that be?
You'd have some guys in black suits and a black van coming to your door.
What if they stay in my yard? Because we have a problem with the neighbor's dog too. My wife has a phobia of dogs, and the neighbor has a big dog who seems like a very friendly dog, but he doesn't keep the dog on a leash, and the dog has run over to our yard before, and my wife gets terrified because obviously he's coming to eat her, right? So she's afraid of him, and we've talked to him and called the police and all this stuff. So now you have these drones come around, they just stop and they do motion detection. When the dog's moving, they just hover and just stare at the dog. Maybe you just do one of those like red pen lights. You know, we're not gonna shoot the dog, but you could pretend like you're going to. This is all recorded now, so this guy had that plan.
Want to restart the lecture?
What you should do is have them, patrol the perimeter of your property.
That's what I was gonna do.
Right, with like red, just
like a scanner thing, just looks like it's scanning.
Yeah, exactly. Like the drones you see in our.
Yeah. Right.
Hook up a dog whistle to it.
I don't want to torment the dog.
No.
The dog seems like a very nice dog. I'm sure he's.
You wouldn't want to be within the drone.
So, we just want him to keep the dog on a leash.
Maybe put like a little Nerf gun on it.
Well, still, I don't think even then, I think you're crossing a line if you even shoot the dog with Nerf things.
Oh, that's
this isn't the dog's fault. The dog's acting like a dog.
The Nerf isn't for the gun. That's for the people.
Oh, yeah. That would be fun. But just that idea of just having kind of a fleet of like 3 or 4 surveillance drones, just kind of sweeping the, and you really do they come around. And they, maybe they go different directions, then come around and they kind of zero in on movement and really freak people out, especially those people like walking their dogs. Intruder.
Just someone walking along the sideway. They enter the property. As they walk along, it
just tracks them.
Yeah.
And one of them has to do like the circle thing that looks like a bullseye, and it's like on the sidewalk, just slowly moving towards that. Oh, got problems. All right, so pass by address means we're passing in a memory. It all came from spray painting my garage, and I have the cameras, I can tell. So in any case, if I give you the address to my house and you go there and you make a change to my house, that's a permanent change. I'll find out when I get home that a change has happened. If I gave you a copy of my house, passed by value, any changes you make to your copy are not going to impact the actual house. Make sense? Now, we know through past experience that arrays are passed by address, which means that any changes we make to this array in here, for example, the changes we're making when we do our swap right there, will be permanent changes. That's where we're spray painting the garage, right in there. When we're taking this element and they're changing places. We're doing that up in memory. That's why we don't return the array here, because we're manipulating the array in its original location. Right? When you go and spray paint my garage, you don't come back and hand me my now spray painted house. You wait and let me find it when I go home, right? You don't need to give me the house back because you changed the original. All right, so that's passed by address. So we'll go ahead, we'll fill our array with random numbers. We'll sort our array. It didn't matter when we grabbed this guy. We could have, grabbed our view group first thing inside of here if we wanted to. Just at some point we needed access to our place that we're going to throw our text views. So we'll sort our array, and now we should have our elements in our array sorted. So there's the smallest value, negative, blah, blah, blah. Here's the largest value. Okay, now, when we look at this sort function here, it's not that bad, right? Now, all of you in here have written this sort, what, 2 or 3 times now? Something like that? How many of you have this sort completely memorized in your mind? Maybe a couple of you, almost. You could probably scratch it out, right? I've probably written it over the years a couple more times than you, right? Now, having said that, could you go and look up the algorithm for a particular sort or something like that and write this if you needed to? Now, does that mean we wasted our time learning sorts? Is there value? I mean, this guy is kind of one of those things where there's enough algorithmic value in writing something that's like it's complicated enough to make you think, but not so complex that it's not doable. So this is kind of a good learning experience when you're learning to program to kind of work through logic like this, be able to ask those questions. All right, so every one of you in here at this point should be able to, if I gave you the kind of the recipe, the algorithm for writing this sort, kind of like if I gave you the recipe for making lasagna, you should then be able to take your programming skills, or conversely take your cooking skills, or similarly take your cooking skills and make the lasagna. If I gave you the algorithm for this, you should then be able to convert that into accurate Java code. Okay, that's something everybody in here should be able to do. Now, what you might not be able to do, and I wouldn't necessarily expect you to do, is be able to recall this algorithm off the top of your head. In fact, as a programmer, we don't memorize code. When I sat here to write this, it's not that I memorized all this Java code. I know how the algorithm works. And I say, oh, we start at bucket 1, we go all the way to the end. Each time through, we try to move, bump the guy towards the top as far as we can go. So I have an understanding of how to make the lasagna. Okay? So after you've done it enough times, you don't need to pull the recipe out. You can just do it. But each time you might solve it a little different. You might name your variable something different, that kind of stuff. Okay? But the punchline is that this is not code I memorized. We wrote this code fresh today. We baked it fresh. But we knew what the algorithm was because we've written it a whole bunch of times. Now, having said that, I don't want you to sit around and memorize algorithms. Over time, if you do a lot of sorting, you're probably going to accidentally memorize some algorithms. I teach a lot of sorting, so I've memorized some algorithms over the years. Having said that, do you think sorting is something that we do pretty often? Yeah. Do you suspect that our languages have built into them the ability to sort collections? Probably. All right. So, since at this point, I expect all of you to be able to write something like this if you're given the algorithm. If I say this is how it works, you should be able to convert that into code. So if you're there, great. If you're not, that's a skill that you need to have. And I would keep practicing sorts until then. But in our case here, I'm going to go ahead and run this real quick just to show you. Then I'm going to ask you about this guy. So we'll do 23. Oh, that's a smaller number. Okay. Yep. Look sorted. This guy threw me off up here, this bigger negative number, but he's actually a smaller negative number. He has less digits. All right, so it's sorted. Did the same work. Is this a lot quicker? Probably in multiple ways. A, we didn't have to write a whole function to do it, and under the hood, it's probably a more efficient sort than we wrote. That I teach as an insertion sort is actually kind of a hybrid between an insertion and a selection sort, but I think it should be called a bubble sort because things bubble to the top. So who cares? Who cares what they're called? It's a mechanism for sorting. This guy more than likely uses an algorithm called quicksort for sorting the data. Whatever. It's fast. Okay? So now, for most of you, this is the first time you've seen this, right? What kind of animal is that guy? It's a method. How do you know? Don't let me down, Charlie. Parenthetical notation. All right, so we know it's a method because of the parenthetical notation here. Okay, is it a class method or an instance method? Class method. How do you know? Or why do you strongly suspect that? So then we ask ourselves, what's this guy? Who is that guy? I think it's a class. Why do you think that guy's a class? Capital letter. Yeah. So that's, I mean, we don't know with 100% certainty that this guy's a class. But since it's built into the language, we've learned that there's this naming convention that classes typically start with capital letters. This guy starts with a capital letter, probably a class. We could take it a step further and say, okay, well, we're using that guy to call this method. Okay, well, methods can only be called two ways. They can be called as an instance method or as a class method. Charlie said this guy must be a class method. Why? Because the way we're calling him looks like we're calling him with the name of a class. And at the very least, we know we didn't define a variable up here called arrays. Right? We didn't create a local variable that happened to be named arrays with a capital letter, even though a break naming convention it would be legal. We didn't write anything called that, so at the very least, as far as we know, this is not an instance. So we can rule it out as being an instance. We can highly suspect it as being a class because it has a capital letter. We know it must be one of those two because it's being used to call a method. So we can, with pretty good confidence now, say this guy is the name of a class that we're then using to call one of his class methods called sort. Okay? So now we don't even need our sort function here if we didn't want it because we're not using it anymore. We're now using the sort function built into the arrays class that knows how to sort collections. Now, just quickly here, if I say arrays dot sort, notice it knows how to sort an integer array, a byte array. You could actually sort portions of an array as well if you just want to get a certain piece of it. Double array, float array, long array. We can sort object arrays as well. Now, object arrays become a little bit more sketch because now you have to have a way of telling how that array is sorted. And what we do is we have a interface called comparable. Remember things that have able in them? So we have an interface called comparable that allow us to tell an object. So anything that is a comparable can tell an object how to compare itself to another object. How to say whether it comes before or after. Okay, so we can choose to allow our objects to be sorted by teaching themselves how to compare themselves to another object. Okay, sometimes that might not make sense. So for instance, if we have, well, let's look at an example where it does make sense. We were talking about dogs earlier. So let's say I have 100 dogs and I want to sort those dogs. What does it mean to sort a dog? Okay, so I have some options, right? I could say maybe I want to do it on height. Maybe I want to do it on weight. Maybe breed, because that then creates some like sorts within sorts, right? But let's just take the first two. Those are relatively simple. So if I create a dog object and I want to teach that object how to compare itself to other dogs, I maybe make the decision. Do I want to do this based on height, based on length, based on weight? Can I have three options, right, for how I want to sort dogs? How do I want one dog to compare itself to another dog? So one kind of object, but as the programmer, I get to choose how I want him to compare himself to other objects. Now, we're not going to get into that right now, but that's just the high-level thing that we could do if we wanted to do that. We can use the arrays sort to sort objects that have implemented the comparable interface because it'll call upon that method. Parallel sort. I wondered, is this guy saying it's antiquated? Because I think red usually means that. Regardless, what do you think parallel sort probably means? Have we done any sorts that feel like they fit into that category of a parallel sort? Well, okay. Well, what sorts have we learned? What sorts have we written? You're right. What sorts have we written? We've written our insertion sort dealy and then merge sort. And how did merge sort work? It was a divide and conquer type sort, right? Where we took our whole list, we said, is this guy sorted? Is it trivially sorted? No. Split it in half, deal with this side. Is this guy sorted? No. Split it in half, deal with one side. Is this guy trivially sorted? As soon as it was a one list, we said, it's only got one element in it, it's sorted. Then we had a merge step to that. That type of sort lends itself to those parts happening in parallel. At the very least, could I deal with the left-hand side, and could you deal with the right-hand side, and then us come back together at the end, and then merge those two back together? So we can do those in parallel, even if it's just divided among two people. But we can further divide it up. Where maybe I do the left half of the left half, you do the right half of the left half, you do the left half of the right half, and you do the right half of the right half. Something like that. We can just keep going with this exercise. So those would be parallel sorts, and they're sorts that would be able to take advantage of multiple processors or multiple threads. Gets a little bit more sketchy. You'll learn about that in the operating systems class, but certainly multiple processes, you get more speed out of it. Multiple distributed computing, you get even more speed. So if you have 5 computers all working on distributing the sort. So I have one computer working on the left half, another computer working on the right half. Assuming if they're the same computer speed, you've doubled your performance. Or pretty close, right? Because your overhead is the communication between the two of them. But you have 2 separate guys working on it, just like if we were raking the leaves on campus. If you split that up among 2 people instead of 1 person, it's going to get done twice as fast, assuming the 2 people can rake at the same rate. But that's a job that could be split up. So that's what they're talking about with the parallel sort type stuff. Okay, but in any case, right now you have a nice new tool in your toolbox that allows you to kind of quickly sort things. All right. So this guy's now doing what we wanted to do. So we've fulfilled our homework assignment with a little bit of added, we'll do 50 so it scrolls, a little bit of added new stuff. Okay, but now what we might want to do is we might want to put a button on this screen that doesn't sort until after we have filled our, maybe we generate the random numbers, we put the unsorted numbers on here. Then we have a button. When we click the button, that's when it sorts them. All right, so let's go ahead and I'm going to not sort them here. Let's comment that out for a moment. So they should be unsorted now in our list. And we're going to go ahead and we're going to throw a button on here. So we'll just put the button right underneath our screen 2 thing. So I'll go to my widgets, button, right there. There's my button. We'll have this guy say sort. All right, and when that button is pressed is when the sorting actually occurs. All right, so now we need to go ahead and write the function that this button will ultimately call, the onClick function for this guy. So we'll go into screen 2. This is going to be public void onSort button clicked UV And for right now, I'll just do a system.out.println sort. I'll say sort. Okay, so now we want to come back in here. We want to set the on click for this button. This little drop down here. I need to move away from the button, then back onto the button. Do I have my drop down now? Yeah, it's weird, but whatever. So there's my on sort button clicked. Select that guy. All right, so now whenever I click this on his on click event, he'll call that function. Let's make sure that guy's working. Always, so notice what I'm doing here. Whenever I do little things like that, before I do anything else, any other logic, I make sure that that button's getting called when I want it to get called. Because I know some of you have already run into this, where you spent an hour and a half on your homework, and then all of a sudden it doesn't work, and you're like clicking the button and it's crashing, and you're not sure why it's crashing. And in the end, it turns out that you had the button hooked up wrong. Yet you've made 50 changes to your logic because you thought it was your logic that was broken. Anybody in here have experienced that? Well, you could use a breakpoint. We haven't really looked at debugging in here too much. All right, so come back out here. We'll say 25. I'll click on sort here. Clicked it a bunch of times. Very least it didn't crash. I'll go to my, it's not the Gradle console, is it? Not the Gradle console. It is Android Monitor. There's my sort. A bunch of times, because I clicked it a bunch of times. All right, so our function's definitely getting called now. All right, so it's in there that we'll actually do our sort. Now, at this point, this array is local to onCreate. I really need to, so its scope lives and dies with onCreate. I need its scope to be bigger than that because I want to be able to access it from within the onSort button clicked. So I need to make that array one level higher in the scope. So this is going to be a private int array, call it AR. Then in here, we'll actually set that array equal to our new array count. So this is where it's now defined. We're giving it its value in onCreate, but now its scope is anywhere inside of the class called screen2. So it's accessible inside of onCreate, it's accessible inside of onSort button clicked, it's accessible inside of sort. Well, we really needed onSort button clicked. So inside here, where we're supposed to sort, that's when we'll actually do the sort. So we'll say arrays.sort this.ar. So now it's sorted. Now, I also want to have a function, maybe this guy, that will go through and fill my array up with my text views. Because right now that's all happening inside of onCreate. So I'm going to create another function here, private void fill let's just call it fill text boxes. And we'll just move this logic here down into there. All right. So now notice it's screaming at me about the VLL. Same issue as before. This guy was the VLL, our vertical linear layout, is defined inside of onCreate. So that means his scope lives and dies only inside that function. I need to access it inside of the fill text boxes function. So I'm going to define this guy one level up. And then give him his value here. Make sense? Really important stuff. We're just moving scopes around, but understanding scope is important. And this is similar to the argument about private versus public versus protected. So the idea being, if I have I've kind of advertised make a variable private first, then loosen the reins if you need to. So we'll make it local here until we determine that, oh, it doesn't need to be local, or I actually need it to be more global than that. I need access to it elsewhere. So if I only need access to it in other places inside this class, I move it up here. What if I need access to it in other classes? What would I do? If I make it public here, actually, that's not a wrong answer. If I make it public here, that would make it accessible to other classes, presuming I had the instance of this activity. What's another way we can make it accessible to other classes? Using core, our singleton, right? So singleton allows us to share variables between multiple classes. Okay. So we'll go ahead and we have the VLL now is defined up here. We give it its value inside of onCreate. That's fine. But this is actually this dot, the VLL. Not required, but that's how I like to write it. This is this dot AR. Okay. So for filling our text boxes, we're going to go ahead inside here. We're going to say this dot fill text boxes. Same logic we had before, but now we're just relying on a function to do it because we actually want to fill our text boxes more than once, right? We want to fill it normally, then we want to fill it with sorted stuff. So this is going to be random array. Then we'll fill the text boxes with our unsorted stuff. Then upon clicking the sort button, we're going to sort it, and then we're going to call this dot fill text boxes. What's going to happen right now when I run this? We have twice the number of numbers. So if I say 25 for the number of numbers, I'm going to get my first 25 are going to be the unsorted 25. Then I'm going to sort that. I'm going to create 25 more text boxes, text views, and then add them to that vertical linear layout. I'll add 25 more elements to it. So say 25, go to this page. So right now, there's my 25 in there. I'll go ahead and hit sort. Now we see there's a lot more. And they are sorted now, but now I have both my sorted and my unsorted. So we need a way of emptying out my view group. My view group is called the VLL. So before I fill it again, I'm going to say this dot the VLL dot remove all views. Because what's a view group? It's a collection of views and other view groups. So when I tell my vertical linear layout to remove all views, I'm taking them, I'm dumping them out. So now he's empty, okay, because all the text views are laying there on the floor and they're going to get garbage collected. And then I'll go ahead and fill it up with new stuff. All right, so there's my initial list. Then I'll sort it. Notice it's changed. There's my smallest number. There's my biggest number. Make sense? All right, what if I wanted to have two different columns? What if I wanted to have my original column be my unsorted, and then when I click sort, it filled in the second column with sorted values? I'm going to need two different columns. How are we representing our columns right now? The vertical linear layout. So I'm going to need a second vertical linear layout, but I want those two vertical linear layouts to sit next to each other. So how do I put two vertical linear layouts right next to each other? Yeah, put them both in a horizontal linear layout. We'll come in here. Still going to be inside of our scroll view. Go to our layouts. Take our horizontal linear layout. Drop that guy. I've destroyed the world. Okay, hold on. This guy can only host. Yeah, but this is actually the error we got was that a scroll view can only host one direct child. So what I really need to do is I need to move this guy out first. Then I can move this guy in. Now I'm allowed to do that. Then I can put this guy in here. So there's my first vertical linear layout. And then I'll make a copy of him. And of course it puts it in there. That's weird. All right, so we're going to call this guy the vertical linear layout unsorted. And this guy is going to be the vertical linear layout sorted. And that's all going to be inside the scroll view. So now we want to get ourselves a sorted and the unsorted boxes instead of the originals that we have now. Let's go back into screen 2. So VLL unsorted. And then we want the VLL sorted. So this is unsorted, and then we'll go ahead and get the sorted version of that guy. So now when we originally fill our text boxes, we're going to go ahead and we're going to fill. This guy wants to know who we're filling. So I'm going to say I'm going to have this guy take in a view group. VG, let's call it linear layout to fill. And it'll be that guy that we fill. And if we want to have some flexibility here, we can always say linear layout to fill dot remove all views first. So any linear layout I give this guy, I could just dump it out first so that I have a fresh linear layout to fill up. All right, so now the guy I'm originally going to fill is unsorted. The guy I'll fill after I press the button is sorted. So when I press the button, I'll sort it, but then I'll fill the sorted version of the video of vertical linear layout. So I should have two separate ones. One is the unsorted version, one is the sorted version. And it's the fill text boxes themselves that remove the views of whoever I passed in if I need to start over. In this particular case, I'm never putting views on top of something that's already filled up. So I'm just emptying it anyways. All right, so here's my original thing sorted. I'll click sort. Ooh. 1 second. To go into screen 2. I want this guy's width to wrap content. I want this guy's width to wrap content, because matching parent squishes all of them. You know, it'll. So our second list was here. It was just out over here. It was pushed off the screen. So now I've said make the width wrap the content of what's in there. And there's the second one. Now, what if I want these guys to be centered on the screen? So I want these two columns to be here in the middle. So what, you have a suggestion?
Try looking through the property and try to do the center. So it's got to be in the function somewhere.
Well, so here's this is the horizontal guy, right? Can't I go to view all properties on this guy? Go to gravity. And make his gravity center horizontally. Every view group has its own gravity. Every view has its own gravity. So I set this guy's gravity to center horizontally. So anything that lives inside of him is part of that gravitational field and will get sucked to the center horizontally. Now, what if I want to put a gap in between these guys so they're not right up next to each other? How would you pull that off?
You go to the vertical linear and then you do the same.
Well, right now, these guys, so vertical linear layout, these guys' width is wrap content. Both of it's to wrap the content. If I set the width to be something other than that, my only option is match parent. That we saw that squeezes it off to the side, right? What about padding? I can set this guy to have padding on the right, maybe 10. Get a little bit more space. I can give it some more. Let's do maybe 30. So we have some decent padding there for our layout. Now, what if I want these numbers? So like right now, these aren't centered. These are left justified, right? So what if I want all of these numbers to be centered? What do I do for that? Continuing to practice what we just learned. Gravity on who? I set the gravity on this guy here, and that made these two columns suck to the middle. How do I make this guy have all of his numbers be centered? Because notice that the things that live inside of this view group are not being bound by the gravitational field here. They're bound by the gravitational field of their container. So if I take this guy and I make his gravity center horizontal, no, I shouldn't have had to save it. It's going to be interesting actually because I am, that was in this one. Those text views are added after the fact. Oh, I said clip horizontal. I want to center horizontal. This should do it, and then we'll call it quits there. Is it centered? I didn't. I think it has something to do with maybe either the padding or that I added those text views after the fact. Those happen at runtime. So we'll mess with that next time. Not the end of the world, but this guy should have his gravitational stuff having an effect on the guys inside. I think it's the padding here that's messing it up. All right, so accomplished quite a bit today. We have view groups inside of view groups. We have buttons making things fill different things. We've learned how to empty out view groups, so now we have quite a bit of tools for doing different stuff in our apps. All right, have a good break. If you're traveling, travel safe. Remember, today is student, faculty, staff Bible study. Free lunch, God and grub. Just go down to the cafeteria, sign in, go grab a tray, take it down to the terrace room with your food. I'll see everybody next Tuesday.